cubic squared. Expand that, out pops the same thing, right? But with a different coefficient, right? So it's negative now. Negative cosine of the sixth and negative sine of the sixth. And so I can add it back to what it was and get twice what it was in terms of other stuff. And then it's a matter of, having the confidence to regroup that other stuff, right? So this is just 3. So 2 minus 3 is -1. And then 3 times black, okay. So then you have to have the confidence to keep in mind you're trying to get to here, and this is all sine. So here you got cosine and sine. So write the cosine in terms of sine, expand that out, collect like terms, and you take half of this because that's twice of what you started with. And that gives you what you want. So sometimes they're pretty challenging, these identities. That was. No doubt. So, I just got, question?
I was just wondering if at some point tonight you would be willing to go over the last 2 questions.
Oh, from the project?
Yeah.
So 31 and what, 28? So 31, I think, was, not sure, let's get that out here. So you can look at it.
I have a copy of 31 if you'd like it.
Yeah?
Yeah, right here.
Um,
There you go.
Okay.
If it's
So this
helpful.
is, so in the mechanics of Regiomontanus's work, we describe a procedure for finding the sine of the arc opposite the desired angle at B, and I believe the picture looks like this, where
You didn't do 31, did you? I didn't have a chance to do it.
this is like 20, 12, and 16. I forget which one is which. What's at the center? Is that A? Or is that B? I think the right angle is C, right?
Yeah.
So, sine of the arc opposite the desired angle at B. So B is at the center, or I think B must have been at the center. So ABC like this. So the sine of B is R, which is your radius, but that's not the radius of this circle. So, or if it is, it's divided into 60,000 different pieces. So we're thinking of R as being the total sine is 60,000. And then opposite over hypotenuse is 12 over 20. And so that's going to be 60,000 times 6/10. Oh, okay, that's not right, is it? So maybe B was up here. So then you'd have 8/10, 48. Oh no, this is right. Okay, so yeah, and so this comes out to 36,000. That's what you're supposed to get, right? As the sine of B. And the second, Regiomontanus gives the the dimensions of triangle ABC. Is this actually a right triangle? How can you tell? Sure, well, 12 squared plus 16 squared is equal to 20 squared, right? That's 144 plus 256 is equal to 400. That's how you can tell it satisfies Pythagoras' theorem. I guess I'm answering question C here, aren't I? So this is, I think, all, so this is, so So sine B is equal to R. This is a capital S sine of B, right? I should have a capital S there. It's going to be AC. In general, it's going to be AC over AB, right? So in our special case, so this is ABC, I think, something like this. This is then 12/20ths, right? And I think apply your formula to verify that sine B is 36. Okay, that's right. We're using the notation capital sign with an S to signify signs in a circle of radius 60,000 parts, right? So that's why for R, we use 60,000. You might say that this is circle radius 20. Well, yeah, imagine a much larger circle of which this is concentric with. And apply your procedure to determine sine A. So sine A is just the cosine, right? And so that's going to be 16/20ths. So I don't remember what 28 was.
20. There's 28 right here for you if you like it.
Oh, okay. Yeah. Right, this one. So we have this picture for these, right? It's a completely different picture now. And so this is A and E, and this is the pole line going from B to D, perpendicular. And we've got the
You see
sun
this is
and
28.
altitude H, AH, and our gnomon, which is our scale, is E to L, right? That's going to be one length, right? So we have that. This is the. And this is the cosecant, capital C's. But so the cotangent of theta is equal to this ratio. So we drop a perpendicular to T here, and it's going to be adjacent to opposite, right? So it's going to be ET to HT. And you can think of that as ET over R divided by HT over R. Is that correct? Why am I doing that with the R? Well, ET over R, which is HE, is the cosine, right? So this is lowercase c cosine, and this is the lowercase s sine. And so the cotangent is cosine over sine. And that then is equal to the tangent, right? So the capital C cotangent is the same as the lowercase c cotangent, right? Because the r comes out to wash, right? It cancels out. So that gives us cotangent. How about tangent? Well, tangent is just going to be the reciprocal of that, right? So tangent theta is going to be sine theta over cosine theta. And the square of the gnomon will equal the product of the cotangent and the tangent of the same arc. Well, tangent times cotangent is going to be equal to 1, which is the same as 1 squared, which is our gnomon, or the square of the gnomon. So that's what they're getting at there. We need to get on to the, we spent a lot of time on this, so we need to get on to the addition and subtraction formulas. So that's in 7.2. These these are identities. I don't know why they call them formulas when they're identities, but whatever, right? Formula is a way of computing something in a different way, with a different formula. So what are we computing? Well, we're interested in computing, let's say the sine of alpha plus beta, and we want to prove that this is sine alpha cosine beta plus sine beta cosine alpha. So for the proof, there are several proofs we can give for this, but if we can prove this, then we get them all. This together with the cofunction identity and the even odd identities get us, there's another 6 of these. There's another 5, there's 6 altogether, right? So I'm not going to write all 6 of them there in the book, but let's see if we can get this one. And the way this is done is to use the definition of sine and cosine well, the proof in the book is done that way. There are other ways of doing it, but the proof in the book is a pretty good one, and it's worth understanding. So look at the unit circle and call this point P naught.